All right, so let's keep going. Using the graph, fill out the chart using interval notation when possible. Because it's a cubic function, my domain and my range are both going to be all real numbers. My domain is every single possible positive and negative x, every single possible positive and negative y. If I want to see my increasing part of my function, I can look at where is this graph getting a higher y as my x's increase. So think about, where is my graph going up and up and up. Remember, increasing and decreasing is a conversation about x's. From least to greatest, I am increasing all the way up to -4, and then I'm increasing again from -1 on forever. Now if I want to talk about where I'm decreasing, that's a conversation about where I'm going downhill. And that is happening right in between these places. So from -4 through -1, my output is decreasing. All right, so when I talk about my minimums or my maximums, I have these local minimums and these local maximum. And then I have these extremes here. So these local minimums and local maximums can be identified as where those turning points happen. So at the ordered pair, over -4, up 8. And at the ordered pair, over -1, down -4. All right. So now we'll take a look at some of these graphs. Absolutely use your graphing calculator. So when we go ahead and we look at this graphing calculator, we'll go ahead and put our equation in. X to the third power plus 3x squared minus 4. When I look at the graph, I'm going to go ahead and zoom 6 to restore my settings, and there I have a quadratic. I can go to, or a cubic. I can go to the table of values, and I can go see all of these important points for me to graph. Over -3, 1, 2, 3, down 1, 2, 3, 4. Over -2, up 0. Over -1, down 2. Over 0, down 1, 2, 3, 4. Over 1, up 0. And over 2, it's way high, 16. So now that I have those points, I can see my graph comes up, down, and then continues up. I know it's a cubic, so I need to be aware of 3 solutions. And this one here is going to be a double root. So is it continuous? Yes. Is it 1 to 1? No. It fails the horizontal line test. My local maximum is right here at -1, 2, 0. And my local minimum is right here at over 0, down 4. I'm increasing from here up to my turning point, and here after my turning point. So that looks to me like -infinity up to -2, union 0 up to positive infinity, which means my decreasing interval is going to happen when I'm not increasing. So here's my decreasing interval. My zeros, luckily, are right there. An input of 2 gives me an output of 0. An input of 1 gives me an output of 0. Alright, so we'll take a look at this next one. Hey, this is going to be in vertex form. So I can go ahead and take a look at negative x minus 4 to the third power plus 1. So there I have my graph. And I'll go ahead and I'll look at and see if there's any points I can graph. So over 2 up 9, 1, 2, 3, 4, 5, 6, 7. That's going to be a little high. So let's try over 3 up 2. Let's try over 4 up 1. Over 5 up 0. And 6, negative 1, 2, 3, 4, 5, 6, 7. So when we take a look at the graph, we can see it's doing this kind of a shape. So my transformations, I have a reflection because of that. I'm moving to the right 4 because of this. And I'm moving up 1 because of that. Is it 1 to 1? Yes. It passes my horizontal line test. Is it continuous? Yes. Is it increasing ever as I move left to right? No. Is it decreasing? Yep. From its very start to its very finish. What zeros do I have? 1, 2, 3, 4, 5. Over 5. Up 0. And I must have 2 imaginary zeros because I have to have a total of 3. Now my y-intercept is going to be a pretty high number. So I have a choice. I can go to the table of values and I can look at an input of 0. Gives me an output of 65. When I have my extrema, I'm going to go with none. Because when I look here, the graph doesn't have any particular minimums or maximums where those are turned. As x approaches negative infinity, y approaches infinity. And as x approaches positive infinity, y approaches negative infinity. This one doesn't have any bumps. So because there's no bumps, I can't find those extremes. Alright, so this last page is finding our curve of best fit. The table shows the total production of U.S. energy. Let 0 represent the year 1985. Find the equation of best fit for the data. So if this is 0, this is equal to 5, and this is equal to 10. Equation of best fit. We might have to use more than one shot and try out the cubic and quartic to see what it looks like. So we'll go ahead and do second mem 712. We'll go into stat and edit and enter 0, 5, 10. It's a little hard with only 3 data points. 64.9, 70.8, 71.0. Second stat plot, we'll turn it on, and then we'll go to zoom 9, and there you have it. All right, let's see what we got here. First of all, we're going to go to the catalog, and we're going to turn on our diagnostic. One to pick it, one to choose it. Stat, and then we're going to go to calc, and then we're going to first run. It doesn't look linear to me, but if we need to see what our correlation is, we can see that our R correlation is 88. Stat, calc. calc. Now let's run a quad reg. Ooh, for quad reg, it is equal to 1. So I kind of like this equation best. Once I hit a 1, I'm feeling pretty good. My y is equal to negative 0.15114x squared plus 1.75x plus 64.9. We need to predict the U.S. energy for the year 2002. When I look at that, when I have 85, 15 years takes me up to the year 2000 plus 2 more, so I'm looking for when x is equal to 17. I'm going to rerun the quadratic regression. I'm going to go to vars, y-vars. He's a fun guy. Therefore, when I go to my table, I can go to 17, and I can see that at 17 years, the production is 61.704. There you go. All right, one last one. Use the data below. Find the equation of best fit for the data. Round to 1 decimal place as needed. All right, we're going to go stat, edit. I'm going to clear out these lists. Clear. And then I'm going to do 3, 4, 5, 6, 7, 8, 9, 10, 10, 11. And then for L2, 0, 6, 9, 8, 7, 10, 18, 29, and 40. We're going to go to stat plots already on. So let's go ahead and look at, ooh, that looks pretty cubic to me. So we'll go ahead and go to stat calc, and let's try a cubic regression. We'll talk to vars, y-vars. He's a fun guy. So we'll look at our graph. Oh, that looks pretty good. I was clicking so fast, I didn't see my R correlation. We'll go back. That's pretty good. All right, so we have a y is equal to 0.22x cubed minus 3.91x squared plus 23.54x minus 40.6. There you go. All right, study, study. Be comfortable with those keystrokes. See you tomorrow.